Okay, I'm going to go ahead and do problems 3 and 4 together here. This is save a little bit of time. First question, number 3, we have this little contest where Josephine and Crystal are both playing, and these are their probabilities of getting certain scores, right? 16, 17, 18, 19, 17, 18, 19. The first question was to find their expected values. Expected values, just this times this plus this times this, so on. So you see my work there. They were both 17.7. Remember, you can also list 1, list 2, and do one variable statistics. It's going to tell you the same mean. Next question says, list all the ways. It says, suppose Josephine scores 16, Crystal scores 17. The difference is -1. List all the combination of things that'll get you -1 and their probabilities. So the combinations are Josephine 16, Crystal 17, 17, 18, 18, 19. They're independent of each other. So if I want to find the probability of this outcome happening, I just multiply Josephine 16, which is the 0.1, and Crystal 17, which is the 0.45. So they did that for all 3 of those. 0.045, 0.12, 0.06. Then it says find the probability that the difference Josephine minus Crystal is -1. Just add those up, right? 0.045, 0.12, 0.06, 0.225. And then the third part, I'll fill in here, says complete the table and then calculate the probability that Crystal scores higher than Josephine's. So the first thing we just did, the -1 here, so that's going to be a 0.225. And then they all have to add up to 1, so I wrote that down here. This is a 0.085. And then the question is, what's the probability that Crystal scores higher? So if Crystal scores higher, since I'm doing Josephine minus Crystal, that means the difference has to be less than 0, right? So this one, and this one. So you add them all up for 0.325 for that one. All right, problem number 4 is a little more difficult, especially the last part of it. Maybe not the beginning. A little twist in here. I'm doubting you're going to see something like that this year, because it's got some twists and turns, but we'll go through it. This was the one we had some temperatures and how many devices were still working after a given time. See if the devices work at different temperatures. So the first thing they asked me to do is graph them. So I found the percents working. I just did 29 out of 30, 42 out of 50, and so on. So it's a quick little picture of it. You see it on this, it will look a little bit better, of course. The question was to comment on trend or pattern. It was definitely pretty linear, pretty strong, and negative. So just a strong, negative, linear relationship. And then the last part, where it gets a little bit tricky, says let's estimate 40 degrees using 30 and 50. So they asked me to estimate the mean and the standard deviation. So I think there's 2 ways to estimate the mean. For using 30 and 50, the first way is 30 was 84%, 50 is 70%, just to find the average, right? It's not the best way, but I looked at their answers and they accepted it. So the average of 84 and 77 is 77%. The better way is to take a weighted average, because remember they didn't have the same amount in the first place. The 30 degrees was 42 out of 50, and the 50 degrees is 21 out of 30, so you dump them all together. It's a much better average because it's a weighted average. 78.75% there. And then the last one is the standard error. This is a tricky problem. So you can see the math. What I did was I took the 42 out of 50. It's like p hat q hat over n1. So that's the standard deviation of that one squared. Find the standard deviation. That was for the 30 degrees. For the 50 degrees, it's 21 over 30 and 9 over 30. That's that number there, the 21 over 30. So that's that standard error. Add them together, standard deviation, square them, get the variances, take the square roots, and then we've got to average them as for the 2 there. So 0.0492, definitely a trickier problem here. I know a lot of people this year had problems with that one, but I think they got that one right. So that's it for 3 and 4.